Good afternoon, everybody. Welcome. This is a session for SIG-VMware, and today we're going to do a deep dive into the Cluster API vSphere provider. Just a little introduction. My name is Loc Nguyen, and my co-presenter is Sidharth Surana. And the first thing, we're both from VMware, and the first thing I want to do is just define some definitions. We internally have been using some acronyms, CAPV and CAPV. CAPV refers to just general cluster API, and CAPV refers to the vSphere provider. And this is the repo for the link to the repo. And the agenda today is that we're going to go over a very brief review of cluster API, but not too in-depth about cluster API. There were other sessions already. We'll go into the history of CAPV and followed by some discussion on architecture and workflow, and then the future directions are for CAPE and CAPV, and at the very end we'll do a demo. So I think I want to start off with a problem statement. Why does CAPE and CAPV exist? Well, the reason is deploying Kubernetes cluster and managing them is hard. Okay. So now on to a brief overview of Cluster API. What is it? It's a project, and the goal is to manage the lifecycle of Kubernetes cluster, and we follow the philosophy of Kubernetes managing Kubernetes. You'll see that in future slides. And the provider code, or the code that provides the glue to the infrastructure. So Cluster API, we use that glue to actually provision VMs or whatever it needs. Cluster API right now is at V1 Alpha 1. That's the API version, and we released that at the end of last quarter, Q1 of 2019. It's built on top of CRD, and it implements a set of controllers. It currently supports two operational models. The first one is Cluster API manages the cluster that it's deployed on. You can call that the self-managing cluster. And the second model is Cluster API manages the child clusters that it creates, and you can call that centrally managed clusters. So when I said earlier on this page that we're following the philosophy of Kubernetes managing Kubernetes, this is what a diagram of that looks like. So on the left-hand side, you have what's called a bootstrap or management cluster. And on the right-hand side, you have the target workload cluster. On the left-hand side, you have to deploy Kubernetes, the cluster API and the provider on an existing Kubernetes cluster in order to use it. I'll refer back to this diagram once we get to the demo. So a little bit about the history of the vSphere provider. So Q3 of 2018, VMware joined SIG Cluster Lifecycle and the Cluster API Working Group. And we transitioned the provider from Terraform to Govimami APIs. And Govimami APIs are just APIs to interact with vSphere. It's a open source project, so you guys can all access vSphere through Govimami also. Q4 of 2018, we transitioned the provider from an aggregated API server to CRDs. We added a central repo for official containers, added automated CI E2E tests, and created a helper OVA, and we tagged that as V0.1. Q1 of 2019, we added a few features, did some bug fixes, and ensured compatibility with CAPE V1 Alpha 1, and tagged that as V0.2. Okay, and now I'm going to turn it over to my co-presenter, and he's going to talk about the architecture and workflow.
Thanks, Loc. So let's look under the covers what's happening when you actually try to use the Cluster API vSphere provider. So what you see on the screen is a quick diagram of when Loc said that you need a cluster to run these controllers. So what you see on the top is let's say the bootstrap cluster or the management cluster where your cluster API pods are running. So you see there are two pods that you will get when you actually deploy this. I refer to that one as the CAPE pod and the other is the CAPV pod. The CAPE pod is essentially running two set of controllers, the machine set controller and the machine deployment controllers. And these controllers are responsible for processing two specific types of resources, which is the machine set and the machine deployment. On the other hand, the CAPV pod, which is more like vSphere specific pod, that is running the machine controller as well as the cluster controller. And they, in general, process, again, the cluster resource as well as the machine resource. And alongside with that, it also processes vSphere specific resources as we have listed in the diagram there. And we'll look more into details, we'll probably when we go to the demo as well. So just from when you do start using or trying out the cluster API vSphere provider, what exactly is supported out of the box? So first of all, the Ubuntu Cloud Images is the default set of images that we support today, using which you can use to deploy Kubernetes cluster. But it's easy enough to support other distributions as well, and we'll briefly touch base upon some of that as well. From the vSphere stack perspective, again, vCenter server, ESX server 6.5 or above, that should do. Kubernetes CNI, Weave is what we have chosen right now to deploy in the Kubernetes cluster that you're going to get out of it. The cloud provider, the Kubernetes cloud provider, of course, we configure it with the vSphere cloud provider with Kubernetes. So there are two different versions. There's an in-tree version and there's an out-of-tree version. Right now, we're using the in-tree version of the cloud provider that you get. But again, we have our work cut out to move to the out-of-the-tree version of the cloud provider as well. CloudInit, I'm sure you will be familiar with some of these tools. CloudInit is the primary tool that is being used to literally like bootstrap the VM when it powers on. kubeadm is another, kubeadm or kubeadm is the another tool that we're using to bootstrap the Kubernetes cluster itself inside that VM. If you want to do a quick start, we also have a helper OVA that is part of the repo, and there are instructions how to build that real quick. So that you can get jump start on trying things out. Let's quickly look at some of the resource YAMLs. Since it's Kubernetes, there's all YAMLs. A few very important ones that I want to just touch base upon. First is provider components.yaml. Now this is a file that when you go through the instruction, this will be a generated file. But the key thing to note is this particular file is responsible for installing and setting up your cluster API controllers onto your target cluster, like your bootstrap cluster or management cluster. Similarly, the other two main ones that I've highlighted here, and again, this is not entirely a comprehensive list, but this is the main ones, cluster.yaml and the machine.yaml. These are primarily what gives you what is your cluster level things that you want to define, and similarly on the machine YAML defines what is that one machine is going to look like, and we'll look into in the next slide some more details about what these are. So let's look at this is a sample cluster.yaml would look like on the right-hand side that you see. Two main pieces of information. First is the cluster networking, so some bit of CIDR selection and things like that. And the second part is the provider spec, which is more provider-specific information. For our case, we have like where is your vCenter server, what are the credentials that you want to use to access those. These are the two pieces of information that you'll find in the cluster.yaml. Moving on, machine.yaml, this is how it looks like as an example. This is really what it's giving you the what is the shape and the size of the VM that you ultimately are going to deploy when you use this machine YAML. So it has things like data center, data store, resource pool, like which defines where that VM will be placed, for example. Then some bit of sizing, like CPU, memory, and so on, forth. Then it also has some specific things like which VM template that you want to clone. This is going to point to, for example, whatever the template that you've prepared in vSphere. Things like NTP servers or cert injection. So this is if you have, let's say, custom certs that you want to make sure that you inject when the VM comes up. So this is where you will define them that will be used. Similarly, again, networking information and so on and so forth. We both support like DHCP as well as static IP from the networking point of view for these VMs. So this is just in a general sense like how the bootstrap workflow works. So you define the machines.yaml, which we just saw a moment ago, which is your intent to what my VM should look like. And then we have some scripts which are right now existing in a file called templates.go, which is in the source code. But these are essentially what defines your CloudNet-based configuration and all. Ultimately, these are the two source of input that gets in. The machine controller running as part of the CAPV pod processes these resources, is responsible for cloning the VM, generating the metadata that needs to be injected in that VM, and then ultimately powers that on. Once that VM is powered on, first thing, CloudNet kicks in. CloudNet takes care of your networking and anything like cert injection, whatever the things that you have specified, CloudNet takes care of that. Then it also emits out a shell script, a boot.sh in temp location, which is basically has all the steps that is needed to be executed to bring this node online. Ultimately, at the end of the day, that boot.sh contains calls to kubeadm. You can imagine the last call is like kubeadm join or kubeadm init to essentially start your, to turn this VM into a Kubernetes node for you. A little bit of the where we are headed towards. So from a CAPV perspective, there is V1 Alpha 2 is the current release that is being worked on at the moment. And there's a lot of redesign that is happening as part of V1 Alpha 2. Some of the work streams I've listed out on this on the slide here. Things like the data model, which is your CRD definitions itself. Some of them might undergo some changes. How the extensions are being used, like how is the provider talking to the main controller. Those things are also under consideration for changes. Similarly, the control plane lifecycle or the node lifecycle individually. And the last but not the least, the image building. Like there is again, work stream for image stamping. How do you reliably reproduce or generate an image that you can reliably use in the CAPV world? From the CAPV perspective, more specific to the vSphere provider, first and foremost, CAPV needs to align with whatever the changes that come out of the V1 Alpha 2 redesign of the CAPV. Then, other than that, we want to align the CAPV feature set along with the other providers. For example, things like add high availability, multi-master support. We don't have that yet, but that's something that we're probably going to get soon enough. Again, as I mentioned, we want to switch to using the out-of-tree version of the vSphere cloud provider instead of using the in-tree version, which is now getting deprecated at the moment. Enable zone support. Again, vSphere cloud provider already has the zone support capability, but it's just that in the CAPV world, we have not yet enabled that configuration option. So again, that's on the way. Similarly, CSI implementation. The moment we move to the out-of-tree vSphere cloud provider, we also enable the dedicated CSI plugin for the vSphere provider. Then some things on more vSphere specific things like the VMware, like the vSphere VM affinity and anti-affinity policies. So we'll start enabling that as well so that when you're defining your cluster, you can express your intent as to how you want your VMs to be placed, so on and so forth. Last point here is more touches upon, if you go back to the last diagram that I showed, like the scripts in template.go here. It's not very useful because right now they're kind of hardcoded in the Go templates. If you have to modify in order to adapt something, you kind of have to modify the source code, which is less than ideal. So one of the things that we want to focus on is kind of externalize that in a way that you can easily modify that so that you can adapt to your needs real quick. Time for a demo. Loc?
So I want to, oops, what happened? Okay. I want to start off by just talking about the demo. So the demo I'm going to show today is from the perspective of a developer. So if you want to start looking at CAPV and you want to get involved, this is how you can start out. So up here, let's go into the, oh. Oh. Okay. Okay. So here I am at the root folder of the repo. And in this folder, we have a make file. And I'm going to step through how you would build it, how you would deploy it, and then and how would you interact with the cluster that we create with it. So in this, we have a make file. And inside of this make file, there is a dev image right here, URL. And you can put in, if you have your own private registry or you have an account on Docker Hub, you can build your own container here and then push it up for debugging, okay? So this is what I have for my container on Docker Hub. And once you put that information into this make file, I'm not going to do it here. I'm just going to talk through it. You can say make dev YAML. And what that would do is it's going to generate an out folder with sample YAML files. And it will generate some certificates for you that Cluster API will use to set up the SSH for the nodes of the target cluster. Once you do that, then you can say dev build YAML, and that will build the container and tag it with the name that you specify, and then last of all, make push YAML, and that will push it up to your registry, and then you can use it. So I've already generated the sample folder. And inside of out, you see that there are a bunch of, let me just remove, bunch of YAML files right here. Now, when Sidharth was talking, he mentioned the provider components, machines, and cluster YAML. There are a couple other YAML files, but we're not going to discuss them today because I really just want to focus on showing a basic bringing up a cluster. So I want to go back to this diagram that we showed earlier, where we had Kubernetes managing Kubernetes, right? So on the left-hand side, you have to have an existing cluster, and then we're going to deploy Cluster API on top of that existing cluster, and from then on, we can create target clusters. So for today, I'm going to use Kind as my bootstrap cluster, or for those of you guys who don't know what Kind is a project in the community that basically instantiates a Kubernetes cluster on top of Docker containers. Okay, so it's really handy, and in order to save time, I went ahead and created a Kind cluster previously. I didn't want you guys to watch it get up and going. So if I do kubectl git node, you see that it is running a Kind cluster right here. Okay, and we go down here, and we're just going to watch. We're just going to watch all the pods that are starting up. Okay. So for this demo today, what I'm going to show you, in the main CAPV repo, there's a CLI tool called Cluster CTL. That's a good development tool to use, but if you haven't played with Cluster API before, you don't know what Cluster CTL is doing. So today I'm going to actually do everything from scratch, so you could actually see what Cluster CTL is doing. Okay. So the first thing I'm going to do is now I'm going to go ahead and apply the Cluster API and the provider on top of this Kind cluster. As Sidharth mentioned earlier, that the provider components is the file that deploys the Cluster API and the provider. So we're going to go ahead. So that is starting up. And while we wait for that to finish, and we'll just move on to the next step. Okay, so it looks like the cluster API system is up and running now. So now we go ahead and create our cluster. You won't see anything happen down here. And one thing that was mentioned earlier was that we currently support vCenter 6.5 and above. We also support ESX for development purposes. So for those of you guys, so right here I have ESX running in a Fusion. So I have nested ESX. And right here I'm showing that we don't have any VMs running. So now we'll go ahead and create a machine for that cluster. And as soon as we do that, we'll shortly see a machine, a VM created and booting up. There we go. So now we have a VM booting up a one node cluster. What we need now, what I'm going to show you now is how do you get the kubeconfig out of that VM so that you can actually interact with that target cluster. And while that's booting up, I am going to, we have this tool, this open source tool called GoVC. If you, I'm going to use that. Okay. Okay, so, and I'm going to wait till the IP address comes up. So this is not the actual correct, okay, there we go. So cancel that. So remember I said that when you do make dev YAML, it generates some certificates. If you look in your .sh folder, you will see vSphere temp and vSphere temp.pub. You could use those keys to SSH into the node. Oh, it'll come back. Okay, so we'll so now we're on the node of the target cluster that we created using Cluster API. So we look around. So the fact that we see an admin.conf folder here, a file here, that tells me that kubeadm has successfully bootstrapped the VM into a Kubernetes node. So I'm going to exit. Now I'm going to go ahead and pull that file out. And we'll just call this target.conf. Oh, yeah, yeah. Now, the system that the OS that we're using today added an extra line in our target.conf, so I'm just going to go ahead and remove it. Oh, it's not there. Huh. Okay. Okay. So apparently it's not there this time. We'll just go ahead and use kubectl, pass in the target.conf file, and we see here that the machine is up and running. So now you can interact with that that target cluster using that target.conf file. Okay. And so now the last thing I'm going to do is I'm going to delete the machine. And in order to delete the machine, you actually have to do it from the original bootstrap cluster. So remember when I do kubectl, if I don't pass in kubeconfig target.conf, then I'm actually targeting the original bootstrap cluster, the kind cluster. So if I do kubectl, the machine on the original bootstrap cluster, when we go back here, you see the machine is there, and the machine is gone. So what I was demonstrating is that if you ever git clone the main CAPV repo, you'll see that there is that CLI tool cluster CTL. It does a lot of this stuff for you, but I wanted to show you guys how everything underneath what it's doing from scratch using kubectl. So at this point, if we go back to everything I showed is on the next page. This is everything I did, okay? But I'm not going to go through this because we just already did that. I think at this point, it's time for a Q&A, and we'll answer any questions that people have. The guy in the back, he had his hand up first. No. So what happens is that kubectl just submits the YAML files, and on Kubernetes we have those controllers that Sidharth mentioned before. It sees the request, and then it will call go vMami to actually provision the VM and boot up. I didn't hear that.
So, I mean, are you trying to just confirm the workflow? Is that?
Yeah, I'm trying to understand. So you run the YAML file. The YAML file run against the API server.
Right.
So the API server communicate with the vSphere API and create a machine.
No.
So the Kubernetes API server in itself is not doing it. So remember in one of the diagram we had like the two pods here, for example. So the pods that are running it, they're running some controllers here, right? So when you submit that machine.yaml with kubectl apply, that creates a new custom resource of type machine, and that type resource is being processed by the controller that is running as part of the CAPV pod.
So it's waiting. It's sitting there waiting for requests to come through.
So this controller right here is what then receives that, oh, there's a new object for machine that has been created, and I need to do something about it, and that's what it basically goes ahead and then says, let me look at the spec, clone it, make it realize it in the real world.
Okay. Sorry.
Can you please talk a little bit about cluster upgrades, how it is done with cluster API, and what efforts are required from CAPV to support cluster updates?
So currently CAPE and CAPV does not do cluster upgrade yet. As part, there is a project that we're working on to do cluster upgrade inside of VMware, and I think we're going to eventually just upstream that into CAPE.
You showed us how to bootstrap the first node of the cluster.
Mm-hmm.
How do you exchange the tokens to bootstrap the other nodes?
So that's like automated. So essentially, the way you saw in this demo how we had like the machines.yaml, you'll create one more. Actually, I can switch to this. Oh, no,
You have to
that-
exit.
Oh,
Okay.
okay. Let's see. So in here, wait, oops, yes, okay. So we saw this machines.yaml file. If we look at that quickly, so this is very similar to what you saw in the slide. Now, the interesting part is now when you want to add, let's say, more worker nodes for your cluster, you're going to define almost identical to this file how your worker nodes, what sizing and things like that, what you want. The only difference between the master node and the worker node, for example, will be in this last line here. If you see in the versions section, for a master node, it also includes something called a control plane version, which kind of identifies that this is a master node and signifies that. So for a worker node, you basically just remove this particular line, for example, and basically resubmit this spec. And of course, if you have static IP, change the IPs and all. But the moment you do that, the controller that is running as part of the CAPV pod, that is responsible for generating an on-the-fly kubeADM token from the master. It ensures that that kubeADM token that it's going to utilize is valid at a minimum for 15 minutes. And I think it caps up at like a 20-minute. So within that time range, if the VM has, like, that's the time range when your worker nodes can basically get cloned, powered on, and the kubeADM init automatically will happen to join the main cluster.
Does it also generate tokens for multi-master nodes?
Yes, so essentially, even when we do support the multi-master, remember, like from the Kubernetes API perspective, you still will be talking to just one Kubernetes API endpoint, because even with the multi-master, then you have to put into the picture is the load balancer for the API server. So yes.
About the Kubernetes, there is some restriction about container runtime, CNCF tagging, when I decide what the type of container runtime to use and so on. So because initially when you bootstrap a cluster, you need to specify channel type, boot type of CNCF tagging as a type of container runtime you need to use. There is some limitation.
So in the current implementation that exists as of today, cluster API, let's say the CAPV, has already made certain choices that unfortunately right now you cannot configure. So for example, in your cluster.yaml, you cannot specify, oh, I don't want Viva, I want, let's say, Calico as a CNI. That flexibility today doesn't exist. But I think CAPI in general, it doesn't even exist, I think, in general as a CAPI level itself. Like across the various cloud providers, it's not a general option that you will find anywhere at the moment. However, that is going to change, and as V1 Alpha 2 comes along the way, I'm sure if not in V1 Alpha 2, but immediately in the next subsequent releases, there will be available these kind of choices in a such that when you are defining your cluster, for example, the cluster.yaml, you should potentially be able to specify, I want Calico, or I want Weave, or I want Planner, or whatever the choice of your CNI, with whatever configuration you might want to pass, being made available as intent-based definitions. But they don't exist as of now today. Today those choices are kind of fixed. But you can, of course, if you're a developer, you can of course clone the repo, make those final modifications. Remember I pointed out, like, there's a template.go file that's really where the main definitions are. So if you want to, let's say in your environment, deploy Calico, in that file you can easily find the snippet, YAML snippet that basically instantiates Weave today. You can easily replace that with the CNI of your choice, and then when you go through the developer process and when you deploy your cluster will then have whatever the CNI that you choose. But again, it's not a configurable option yet.
Yeah.
On the same plane, there's integration between the NS6 feature and SIG-VMware.
What is it?
So the NSX feature, so NSX, the CNI for NSXT is called NCP. Right now, as of today, for example, NCP is not an open source project, so there is no way in the open source world directly where we can actually instruct cluster API to deploy like the NCP plugin. But hopefully, again, I don't know really what the future would be, but hopefully, I think it might become a reality that, along with the other CNI choices, NCP will or potentially may become a possible CNI deployment option if you have NSXT already in your environment. The mechanics of that might, again, I don't know really at the moment what that would be, but definitely should be possible in somewhat near future, I would say.
Okay. Any other questions? Okay. Oh, okay, go ahead.
My question is, are geared a little bit more towards vSphere than Kubernetes, and it has to do with which credentials you need to make vSphere cloud provider use in the long run. I know that the cloud provider vSphere has at least preliminary support for solution users, and also non-commercial users logging in using a password. What are your thoughts on what you will use down the line? The problem being that the Persian users will have password policies and expiring passwords.
Right, so right now it uses username password based credentials, which of course always have the caveat that, okay, what if somebody rotated the password or something like that, and now how do you update it? So those are some of these operational challenges, but unfortunately at the moment, the current, again, I'm only talking about what the current code is. It doesn't really handle, like, for example, the password rotation. You deploy, you can of course manually go and update that, but it's not really automated very well. Now, as far as other type of credentials mechanism that may be supported, things like, exchange, I think CERT-based authentication, things like that. I think CAPV is really more of a tooling right now to kind of enable the cluster. At the end of the day, those credentials are being used by, let's say, the vSphere cloud provider. Now, so vSphere, the moment, like, I'm not entirely sure if the vSphere cloud provider, especially in the out-of-the-tree version of that, currently supports, let's say, a solution-based authentication mechanism at the moment or not. But it
does, yeah.
Oh, it does. Okay. So yeah.
The key and the cert are actually put into the username and password fields.
Yes.
But it still looks at is it encoded, then I'm going to use solution users, not. So it's preliminary support at least for that.
Right. So essentially, in theory, then essentially, even with what you saw here, then because what the credentials and how they're used are pretty much identical to how any vSphere APIs when you're consuming going to be used. So I guess even today, when you have so the CAPV supports a secret-based definition, which is which is actually identical to how I think the vSphere cloud provider supports. So you kind of generate it in the same way. So if you can use solution users there, then I'm guessing, again, I haven't tried it myself, but you should be able to use this here as well.
Okay, I think we're at time, or we're actually a little bit over. So, if there are any other questions, we'll stick behind and answer them. But the last, just a last thing, we want to thank you guys. If you guys want to reach us, there are 2 Slack channels under the Kubernetes organization, Cluster API, and SIG-VMware. We have bi-weekly meetings on Monday at 1 p.m. Pacific Standard Time. The next one is on June 4th. And last of all, this is the Git repo. So thank you all for coming.